Hello students, today we will calculate kinetic energy of this electron which is moving in particular shell number n in hydrogen atom. So what is the kinetic energy of electron? What is potential energy between the nucleus and the electron, and what is the total energy of this hydrogen atom? Okay, so for kinetic energy we need one formula which is half mv. So there was a scientist, his name was Rutherford, who used cleverly one concept to calculate kinetic energy. What he did, he knew that centripetal force required here to move the electron on a circular path is given by the electrostatic between this electron and the nucleus. Okay, so for anything to rotate in a circle we need centripetal force. So that centripetal force is coming from the electrostatic, the attraction force between these two. So centripetal force we know is mv square by r by the knowledge from 11th grade. Okay, so we should know what is m here is mass of electron. Okay, what is v here? Speed of electron. What is r here? Is the radius of atom. Okay, and what is electrostatic force? Is 1 upon 4 pi epsilon naught q1 into q2, correct? Product of these two by the knowledge in first chapter. We have potential, the force between these two is this. So what it will become? mv square by r 1 upon 4 pi epsilon naught. q1 is E, q2 is ZE. q2 is the total charge in the nucleus. Total charge in the nucleus is number of protons into E. Correct? Number of protons into E. So what is Z here? Z here is atomic number. Atomic number which tells how many protons are there. And each proton has charge E. The total charge will be Z into E. Okay? R is this. And 1 power of R is cancelling. Okay? And for hydrogen, Z is 1 we will take. Only for hydrogen atom, because calculation we are doing. So it will be mv square is 1 upon 4 pi epsilon naught into E square, because Z became 1 by R. I hope you got it. Okay. This is mv square. But for kinetic energy, what do we need? We need half mv square. Okay. So can I multiply by half both sides? Yes or no? So this will become kinetic energy. This is nothing. Half mv square is kinetic energy is this into this. What is 4 to the 4 to the 8 pi epsilon naught into E square by R. So this is my kinetic energy. This is good, important formula and easy. Okay. Now we will calculate the potential energy. Okay. So for potential energy, in the first chapter we learned what was the formula for potential energy was 1 upon 4 pi epsilon naught q1 q2 by r with minus sign. In the first chapter we have learned the potential energy of a charge which is next to another charge. q1 and q2 is this. Okay. If you don't remember, you just memorize it right now, that potential energy is this between two charges, and it is always negative. Potential energy is always negative. Kinetic energy is always. So what will be the potential energy? If I simplify it, it will be minus 1 upon 4 pi epsilon naught. What is q1? Is E into ZE by R. Okay. And what is Z here? Z we are taking 1 only. Correct? Z. So potential energy will be, let me write down, minus ZE square by 4 pi epsilon naught R. Okay. So this is potential energy. If I put 1, the potential energy will be minus E square by 4 pi epsilon naught R. Okay, because Z I have taken 1. So this is the potential energy. Now let's do total energy. So what is total energy formula of electron? Kinetic energy plus potential energy. This is the formula, right? So what is kinetic energy is this. Okay. So let me write down kinetic energy is 8 pi epsilon naught r and in numerator is E square. This one minus, because potential energy you can see is minus E square by 4 pi epsilon naught r. Is it clear? Now what can we do here to calculate full? What is the LCM of these two? Is 8 pi epsilon naught r. Correct? So what will happen? This will be E square minus, this is 4 2s are 8, minus 2E square. Perfect. So what is the total energy we are getting? E square minus 2E square is minus E square by 8 pi epsilon naught r. So see carefully. This is total energy. So guys, we got formula for all three energies. See, this is kinetic energy. This is potential energy. And this is total energy. So remember, kinetic energy is positive, potential energy is negative, total energy is negative. Remember that. Okay. Now we will see the relationship of these three energies. If you watch carefully, if you observe little bit, kinetic energy and total energy formula is exactly matching these two. Yes or no? The total energy is equal to G, that kinetic energy is nothing but minus of total energy. You know? Because these two are same, only the minus sign is there. And if I observe potential energy, what is potential energy formula? If you observe these between these two, potential energy and total energy, what is the relationship? This is 4 here, if you observe, and this is 8 here. So what do you think? Total energy, potential energy is 4 pi epsilon naught, and this is 8 pi epsilon naught. So it is nothing but double of total energy. Correct? How? If I multiply total energy, if you multiply by 2 twice of total energy is minus E square by 8 pi epsilon naught r into 2 करके देखिए तो this 2 होगा, so it is nothing but minus E square pi epsilon naught r twice of total energy, and which is the same as we have potential energy. So can I say safely that potential energy is double of total energy? So this is the relationship we will be using a lot for numerical or for MCQs. So this is a very important relationship. Or in other words, there is one more way to write it. Write down total energy is minus of kinetic energy, or we can say half of potential energy. This is the same thing we are writing this way. Okay, pause it and you can check by yourself. The total energy is equal to minus of kinetic energy, and here total energy is half of potential. So this is a very important relationship for your MCQs or derivation for big questions. Hi everyone, see you next video.